Yeah, yeah, like so. Let's require. We could make the PCB for the tumbler so that you could also use it. Right? That was my idea. So, but I think the rover you have, it's the dimensions are a little small. So
Right. I guess I'm operating under a different theory of progress, wherein we need to learn to produce many different PCB boards, and doing so is cheap. It's just time consuming to figure out how to to figure out the process. And so I
okay,
would rather take the stuff that we have learned through the Tumblr project and like, well, let's adapt this to a new one. So I'm working on a board right now that like is not actually the final thing for anything, but happens to. I think I can actually make it without surface mounted components because I have everything to solder in, and I'm just going to solder in pieces together to basically make a PCB version of my little motor controller that I made for this one, just so that
okay,
I can learn how to make a PCB.
Sounds good.
yeah. But like, if you make a PCB that you could use too, that would be like a test of common platform for everybody, because the same platform would work for your rover and then for Tumblr, and then with some
True.
additions.
I think hopefully things converge, but I think
Yeah,
there's a lot of like learning and experimentation probably that kind of needs to happen. And it's probably
yeah,
cheaper for us to like produce the design ourselves. I mean, sorry, to have the boards printed to a local company and then have them delivered
yeah,
individually, right? Than to like do a big run.
yeah.
Maybe. I haven't looked carefully at these economics, but it seems like it's kind of
But the
approachable.
printing the boards is like 20, no, maybe within $20, or maybe with maybe less than 10.
Yeah.
It's just the assembly that and the component parts that are costing more.
Yeah. I did some shopping on a component part last night because I was like, you know what? I've been focusing on these like L293Ds, the literally cheap chips for doing like an H bridge, because it
Okay.
came with the Arduino quit kit that I think Atesh and myself both have. It was like, here's how you do a motor driver, and it's just like these really cheap chips. I'm like, hey, I wonder actually if there are more advanced things that cover more of the capabilities that I want. And yes, it turns out there are. For like $2, you can get a chip that like does 4 motors, has built-in like current sensing and all kinds of extra motor control features made by like Texas Instruments. However, you
Yeah.
can't actually source them from anywhere, or they become available once or twice a year, and then then you got to try to grab it when it becomes available. So that's interesting.
Texas Instruments uses this, or the tumbler is this one.
What is it?
Good.
A T?
Uh, TB6612.
Yeah, I didn't even run across that one. Apparently, there's a lot.
How do you connect it? I see that
Uh,
it's more.
it's here. So basically, so this is VM is the motor voltage, and then yeah, so it generates PWM for the control
Okay.
of the motors, and the motor
What
has the positive side and negative, and then
what
two PWMs for A0. These both of these will pins will go to one motor, and then they will control the direction it goes in.
what voltage can it supply?
VM. So VM can be anything.
No,
Well, not anything, but
12. Okay.
I think it's rated at 15 volts,
yeah. So around six
and
to
it
12 volts.
supports 1.2 amps. No, 3.
Yeah.
Yeah,
Oh,
1.2
this is not.
average.
This is
Sorry.
not a Texas Instrument. This is a Toshiba
Yeah.
part.
Yeah, so I spent like an hour, and that was just with Texas Instruments. So I can imagine. Apparently, there's lots of different variations of this sort of thing. This seems pretty close, just slightly more powerful than what did I say? L293.
Yeah, and it seems like it has. It's not a simple edge bridge.
What else does it do? Guess I can just open the data sheet here. What do we got here?
Yeah, it is a edge bridge.
It actually has short break and stop modes.
What is
maybe
short
that's a.
break?
I don't know.
They don't tell the entire working inside, it seems.
Yeah, that's kind of weird. Just say the Texas Instrument data sheets were much better.
Is
No
short
pressure,
break,
Toshiba.
is break with a E at the end or without?
Short break with an E on the end.
But they show the current direction here.
So here's there's a chart that has the control functions, and I think that it's got. No, this is the same number of inputs.
Okay, so Stack Exchange says that short break shorts out the motor via the power of the ground rail.
Oh, so it's using like resistance of the motor itself to like slow everything down.
Yeah. And
Oh, I see. Based on the logic chart, it's that if you enable, so usually there's like 2 pins that tell you which direction the motor is going to go, and then one that tells you how fast. And so if you set everything to low, the direction the pin's to low, but then the current to high, that makes it like full on stop, as opposed to just being off, I guess.
No, there are 2 control pins, one PW and one. So there are 4 controls, right? 4 input pins. So standby also controls the direction in which it goes, and also the mode. So if you have like suppose A0, what is the pins called? A in 1 and A in 2 as high, and then PWM could be either of them, and then you put high on the standby pin, then you will get low and low on the out 1 and out 2, and then the motor will break.
yeah.
High, low. Oh, standby is taken high.
And then if in is low and in2 is high, and PWM is low and standby is high, then you get a short break again.
Yeah, again.
It's teeny tiny.
Okay, the MOSFET based edge bridges are more efficient than the BJT ones. Okay, L293D is a BJT, and then these are MOSFET based.
Yeah, I think the peak current that it allows is like 1.2, whereas this one's a 3.2.
Mm-hmm.
But I've got 10 of them for like $4, so.
Yeah, but when your
Amazon.
robot is stuck on Mars because you were cheap,
I just have to wire up a whole bunch of them and allow it to switch between them. I'm sure that'll work great.
Yeah, so my idea was basically take this out, this Bluetooth module, and have two sockets, one for the Arduino Nano and then for the ESP32 or this. What was that? Yeah, this one. So this way we have everything, whatever we need.
How are they handling cell plans?
They don't. So the same you will have to buy, but they have some
like an eSIM or
collaboration.
something? Or
No, they have a SIM card slot, and then you buy the SIM yourself.
Oh, I see.
But I think this Soracom company has some collaboration with them. But generally, one would buy from the local. I think many of the these telecom vendors have these data plans for IoTs. At least in Finland, we can buy the SIM cards which are dedicated for IoTs.
Right.
$100.
So where are you on the design?
I haven't started it yet. So just I wanted to know.
For this
like,
one. Well, what about the
Yeah.
one you worked on last week?
That will come tomorrow.
Okay.
That will arrive tomorrow in the evening. Yeah.
Exciting. Fully assembled.
But I'm traveling to some other part of Finland for work, so I'll be not here during during the week. So I'll have to wait until maybe Friday to get it. Yeah, and then probably I'll make the same dimensions as the tumbler board. Remove this Bluetooth part, and yeah, and take this schematic as it is almost. And yeah, change this part maybe, the voltage
What is
regulations.
the I/O interface slide again? What were those?
These are just railings for pins. These are not needed on the right side.
Oh, it's exposing the pins of the Nano.
Pins on the it's exposing the pins on the PCB.
Got it. As like test points or something.
Yeah. So what are you planning to design?
Here, I'll show what I got here. Uh-oh, maybe I can't. Forgot I haven't. Okay. I can't share my screen, but I have to restart the computer to do it. I forgot I haven't done it on this computer yet. It's like, well, it's a security change. Obviously, I'm going to have to restart. So the idea, actually, I'll just send a screenshot of my schematic here. And then let's see. I put it in the Discord thread. The idea originally was to just reproduce the motor control kind of daughter board that I made for the original, or whatever you call them, shield for the original, for this rover. That was just like a Arduino, I guess, that popped on, where it controls two motors, but do it for this board we were working with, the Freenove. But then I got greedy and I was like, what would be great if I could control 4 wheels instead of just 2? But there are not enough pins available to do that. And so that led me down 2 paths. One was like, well, what if there are different chips that I could use? There are, in fact, different chips that I can use, but they're probably harder to work with. But then I thought maybe I could do it this way, where I actually configure the enable pins to be joined together. So though you can control the speed of each wheel independently, you would have to choose to make, like, the left side of the rover has to go forward or backwards. You can't have like the front right wheel go forward and the back right wheel go backwards.
You can use this one, right? Because you just need to generate the PWMs. So you can use this chip.
What chip is that?
It's a I2C controlled PWM controller. PCA 9685.
But do those work for brush?
So it's
brush DC
it's not
motors?
no, you will need this in front of the. So this is like a PWM controller, and they are like kind of like in majority of the cases used for LED controlling. So if you have a LED matrix or lots of LEDs to be controlled with, and the brightnesses, you would use something like this, and then you would interface this with the microcontroller, and then the microcontroller would send messages via I2C, or they are also available in SPI format, like bus. And then you would set some values in register, and this controller would keep generating a certain patterns of PWMs on certain channels. So this is a 16 channel. So you could basically control 16 like motors with this. You just need a L293D kind of chip in front of the PWM, and then that L293D will switch the voltage. Yeah, if you want to control lots of motors, then this is the way. But otherwise, I think your solution is simpler. Where did it go?
I can't quite picture how you, like, how much current can you put through that board?
No, you don't put the current through this. The current goes through the L293D. This just controls the PWM.
Oh, I see. Yeah. So that was roughly the direction I had.
Yeah,
So the next direction I'd gone down was like, okay, well, if I want to save pins, maybe I can use another chip that would allow me to like set via I2C what those are, and then I can use my PWM. Well, yeah, to do something like that. I think 100% works if you're adding another component. And then I started looking at what other chips there are, and in fact, there are Texas Instrument and probably others chips that do all kinds of wild things in just one chip. I'll drop that one in there too. Where you can have one chip that does like all these things and then speaks I2. You just program it via I2C. So you set registers to like enable and disable or set current limits or voltage targets for each individual
yeah,
motor.
but all these pins brought out for this on this vroom. This is the vroom footprint, right?
Yes. And so yeah, so the current design, there's enough pins to make this work the way. I mean, whether it works or not is I still don't know, but in theory, it seems like it might work.
But if you don't want to use the camera parallel pins, then basically you have lots of pins available.
Right. Or probably there's some way to rig it up to where I could like stop and use the camera, not control both at the same time. It seems like
I
that
don't
would be
know if
possible.
that's possible.
I
Because
noticed that it said somewhere in one of these data sheets about the logic not losing voltage when you operate the motors. Is that a real problem? Can it affect stuff like your camera?
You mean like the motor causes a voltage drop, which causes the logic to drop out?
Exactly.
Yeah.
Or just go down, it doesn't have to drop out. It's enough that
I hadn't maybe thought about this too thoroughly, but I think I was intuitively using the same design that I have on my Raspberry Pi based rover, which has two separate batteries. One is the high voltage for the motors, and the other one is like a USB battery pack that just plugs in via USB-C to the compute. Just because of that potential problem, I guess. Although in practice, I have rarely had to charge either one of them, and then my rover is just one big heavy battery with a little tiny chip on it. That's basically how it is. But yeah, I would have to add to this circuit a way to convert from to 3.3 volts, I think. Drop the 6 volts to 3.3 volts to power the chip.
Yeah, you could just drop in a simple LDO. If you search LDO on the components library, you'll get many of them. Probably it might be better to isolate. That will at least separate the VCC of the logic from the VCC of this.
Yeah.
Right. The other little thing on the left is what I was working on right before the call, which was to have a what do they call that? A split resistor. I want to measure the voltage on the battery on one of the analog pins.
Okay. So this is what this is on GPIO 14.
Yep.
So 5:1 ratio.
I haven't actually done the math. I just asked ChatGPT to do the math. So whether that's correct or not is unclear. I should probably do a little more checking.
So it will generate 10 by 60, right? So it will generate 1 volt here, I guess.
Yes. Yeah. That's the goal. Yeah. But I did manage to build that ESP32 schematic thing. That's all custom. Did it myself. Very proud. And the footprint is then just like headers that we'll drop it down into.
So did KiCad have the ESP32 footprint? Or
It has an ESP32 footprint, but like the chip, it doesn't have like one for a built development kit board. So I had to build. So I did that one myself, so it'd be more clear. I mean, it's like pretty close. Mostly, it's just the pins are being exposed.
Okay.
Directly, but this seemed like it made a little bit more sense. And then,
but how did you know the dimensions?
I measured the dimensions because I wasn't on there, but I have the header pins that I'm using, so I know what I need the holes to be.
No, but the distance between them on the parallel pins.
Oh, I measured it.
Okay.
And it's 25 millimeters.
Okay.
But yeah, I couldn't find it listed anywhere, which is annoying.
Yeah, because I had asked them to send me the schematics, so they sent me the schematics of that Freenode board. Yeah, but it doesn't have. Yeah. They sent me the schematic, but it doesn't have the footprints. Just this, not the PCB.
Yeah,
just the schematic.
Well, when I measured it, it seemed like it was exactly 25 millimeters, which the fact that it was that close to being exactly 25 millimeters made me think maybe that's what they actually did. So hopefully that's right. I don't know. And then it fits in the headers that I have, which are like 2.5 millimeters spaced. 20 by 20. 1 by 20. So hopefully that works. But also the nice thing about this is that I think all the components I can do it in like assemble myself through hole style as opposed to having to deal with surface mount stuff or having them assemble it. And I have these components, so it should be cheap, fast, and then I can just do some soldering practice to find out that it doesn't work.
I think this will work.
Yeah, if I wanted to do one of the more advanced chips, which I'm kind of excited to try to do, although I probably can't get the one that I really want, but that's like a surface mount, lots of pins that need to be. I don't know how that would work. I think I have to have that assembled.
Here, so you are not trying to control 4 motors independently, right? You're controlling 2 motors together.
Yes, by direction. So each one has its own PWM, which controls like the speed. So I control the speed independently, but the direction will have to be joined together. Okay. Now, whether that's a legitimate thing to do on this chip or not, I don't know, but seems plausible. So I got that idea because the rover kit that I got that we talked about last week, I think, it actually doesn't run all the motors independently. I was like, oh yeah, I guess I could do that, couldn't I? Run them.
You mean the
so it's
which
got
one?
6
The Galaxy
motors. Yeah, the Galaxy rover or whatever.
Yeah.
It's got 6 motors, but there's only really 2 channels. So at least I have sort of almost 4 channels, but not quite.
So what controller is that using? The motor driver?
I don't know yet. Honestly, I don't know. It just arrived a few days ago, and I haven't opened it up yet.
Okay.
I was reading through it, and then I was like, oh, I'll just order whatever.
Okay.
The more advanced chips do really cool stuff like stall detection, and it counts. It like detects via the current how fast the motor is spinning, or it thinks that it can. And then you can also, rather than using PWM to control the speed, which could vary based on like the battery voltage,
How
you
does
can
it
set
report it?
what
How does it report that?
it reports it back over an I2C bus, so you can read like registers on the chip to get like whatever data out of it that you want. And I think there's also like interrupt pins that you can wire up to like get instant notification of like a fault or something. And then yeah, you can set this when you set the speed, it adjusts that target voltage sort of independent of what the battery is setting. So it's supposed to like give you consistent performance even if the battery is draining, which is kind of neat. But yeah, maybe that'll be revision 2. If I can find a chip I like. It also would be nice to do stuff on I2C buses as opposed to fighting over just a couple of little pins.
Yeah.
Is that how the Spider bot motors work? Is it like an I2C bus or some other bus that like?
It is a serial bus with a separate data channel and voltage channel. So it's 3 wires, ground, voltage, and data. And it's a serial bus, and each item on the bus has a address.
Yep.
And the motors themselves are smart motors. So not only do they get digital commands, they can also give you digital responses like my angle is such and such, my temperature is such and such.
They were dynamic cell servers, right?
I'm sorry?
They were dynamic cell. This company's servers on the SpiderBot.
I don't think so. Just a second. They are, they're made by High Wonder. So it could be that High Wonder only packaging them.
Could be their own clone of that concept.
Yeah. In any case, it's a 24-volt high voltage. Ooh, puppy pie.
Or Jetson Hexa.
Bestseller.
Or is it not?
It's not quite
What's
one of
the?
those. It's similar, but it's not. See,
They
it
have their
doesn't
own
have
servers.
those little tabs on the sides. It's similar to what says High Wonder HDD 45H. Except I have the 20. So
When these servos say they have 360 degrees, does that mean they can spin continuously?
Yeah.
no, wait, there's 2 modes. One is continuous mode and one is servo mode where you tell him what angle to go to. So he's saying the encoder can cover 360 degrees. But that is independent of the separate spin till you drop mode.
Yeah.
Why are these servers so expensive from
Like I
Dynamic
said,
Self?
it's a digital servos, and they include a gearbox.
No, but High Wonder also has similar servers, but they are much cheaper.
Yeah.
Now,
More metal parts.
$300 for a server.
well, High Wonder says that they are metal gears as well. How much torque does this thing provide? First of all, look at the speed, 4.5 megabits per second, and it's 4,000 positions.
Oh, it has a Cortex M3 inside. That's why.
Okay, but that adds $200.
No, well, the control is like a few dollars, but the firmware inside the M3 might be costly.
Maybe
I
the
think they are
price
charging. They're
10.
charging for the firmware inside.
Yeah.
Anuraj, you better be starting like a YouTube channel to review servos, and then you can get them for free.
Yeah. But make sure not to
Okay.
give them this recording as an example of your work.
Two and a half Newton meter torque.
See, that's Metal Gear, and it's 25 kilogram centimeter.
25 kilogram
So
centimeter.
0.25 kilogram meter. So it's 2.5 Newton meter. Sounds the same.
Yeah. Okay. 485 multi-drop bus.
You link together a whole bunch of these motors and the servo controller. That's like a lot of compute.
Yeah, but how do you have them do something with that?
Then you need another computer
Oh, okay.
to tell this computer to tell the
Yeah,
other
but it's
computers.
supposed to be a distributed system. One of the computers takes charge and tells the other ones what software to run.
And at the top of it all is a GPU running a large language model somewhere.
Okay, that's a good question. Does anybody make a motor with a GPU inside?
Why do you need that?
If I knew the answer to that, I'd know if anybody's doing it. Well, there's something called the GPU engine. Well, you can use your Jetson to control DC motors.
Yeah, but the GPU is not controlling the motors. It's the CPU on Jetson.
Well, I know who to ask. GPU to control an electric motor, and why would you want to? So ChatGPT says definitely you can do that. And you might want to do it for robotics.
Well, it would say that, wouldn't it?
No, actually, what it's saying is you would use machine learning to integrate the data from the sensors in the motor in order to do it.
Maybe in large motors, you could use it, right?
That just
So
said, we'd have 16 motors. So you have 16 motors, each one's giving you a stream of data, and, we want to crunch it.
Close to the
well, the
source.
MCUs can crunch it, but if it's like clearly really large motors, industrial scale motors, maybe then you could
No, I, I,
use
I know
them.
an MCU can crunch it, but an MCU can't use it to update its model of what these motors are doing. I mean, what did we want to do? We wanted to put a machine learning model on the rover to learn how the wheels are working and when it gets stuck. So you just move it one level down.
Distributed compute.
Yeah. Okay, we are approaching the top of the hour in 5 minutes. Yeah. I'll try to start designing the board for the tumbler.
Yeah.
Yeah, and for red, I would at least drop in some voltage, like a regulator here, for directly connecting.
Yeah.
But how is it on your board right now? On the one you are soldered?
The one that I soldered has. How do I have that? I have that Adafruit charging power boost thing. I think it's
Okay.
you know what it is? It's that this board runs at 5 volts, and so then I just run the motors at 5 volts. I never really had like power dropout problems, but I had plenty of other problems, so it's hard to know which one was which. Loose wire problems is more likely to be my problem on this particular robot.
Okay. So yeah.
Yep.
Anything else
Cool.
we want to discuss today?
Mm. Yeah.
If not, then we meet next week.
All right.
Yep.
Catch you all later.